Hello everyone. So with this video we are starting a new module of air handling units. Which is commonly called as AHUs. For this introductory video, what I am going to cover is I'll give you a complete picture of how an AHU works, what are the background processes, what are the equipments which are involved. So you have a complete understanding of from where air is coming or from where the water is coming, how the water is cooled, how the water is heated, where it is used, how it is transported, everything. And then from the next videos, we'll start looking at individual different types of air handling units which we have. So obviously what we usually have are air handling units, but we also have our no duct. So air handling units have duct and a transport system to transport our air from one location to other, usually from outside of our homes to inside. But we also have an air conditioner, which is a compact version of our air handling unit, which gives you cooling or heating effect. So in an air handling unit, what we usually have are fan, cooling or heating. Cooling and heating coil, usually we'll have both type of coils in our air handling unit. Then we have valve to control flow. Then we have dampers also to control, but this is the control of water, H2O. This is the control of air. Then we have ducts, and we can have some more complex things which are related to control systems, a microprocessor or something. But these are the common things which we have in an air handling unit, which are on the secondary side. So this is very important. We have a complete understanding first of what the primary side and secondary side are. So the secondary side will have AHUs also, the delivery system, in fact, which contains all these equipments or structures. While on the primary side, what we have are cooler or chiller, then furnace or boilers, pump, and such. So what the system is or what the setup is, we can have a central utility plant. So this will have some coal supplied to it, or gas, and electricity. It will have air for the compressor and water coming from some local supply station. And then we have a room or building, BLDG, of interest. And in between this, usually in the building of interest, will not have the chillers, boilers, everything. If we have multiple homes or multiple buildings, we'll have one central utility plant, which will be a source of cold and hot water, right? And from this we'll have pipes. This will be for cold water, and this might be for hot water. And for the building, what we might have is outside air, which is used up, and it will use cold water or hot water, and it will have some exhaust air. Right? So now I believe, and we'll have some pumps maybe fitted over here or some pump maybe installed over here. It depends on the design. But this is the overall picture. We'll have some place where the cold water and hot water are generated. The hot water will be usually generated using a boiler. The furnace is a slightly older version of things which is not as efficient. Boilers are much more efficient. Or for heating of the buildings, we can also use heat pumps, which is a new idea and much more energy efficient idea. But usually what we would have right now will be a gas operated boiler to generate hot water. And the cold water will be generated using chillers. So a chiller plant would usually have a refrigerating cycle, compressor, pumps, condenser and an evaporator, which will generate some cold water. The cold water will be supplied to the building of interest, and in the building of interest we'll have cold water, hot water supplied, which will be going to cooling coil and heating coil. The fan will take in some of the outside air. There will be some walls and dampers. So the wall will be used to control the amount of water used. The dampers will be used to control the amount of outside air which we are using or taking inside the building, and the amount of conditioned air which is going out of the building. So it depends. There will be some ducts in the building which will be useful to transport the outside air from one location, from one corner of the building to another corner, wherever we want to supply our conditioned air, maybe cool air or hot air. And some control systems, some actuators, some motors, etc., which will control all the dampers, walls and everything. And this overall whole structure, which includes everything, is called an AHU. So now I hope you have got an overall picture of how an AHU is. And if we compact everything, all of these equipments into a very small structure, maybe some cube of 2 meters or 1 meter by 1 meter, that is a compact AC what we have, or air conditioner, rooftop package, which are usually put in a remote location where there's not much requirement of a setup like this, where we need a lot of large equipments. These boilers and chillers are having maybe a capacity to handle tons, maybe 1 ton, 2 ton, 3 ton, or 10 tons, 20 tons. While if we have a small office space which only has a requirement of 1 ton, or a flow of just some cubic feet per meter, like maybe 1000 cubic feet per meter, then we do not need to invest everything to get a air handling unit setup. Over there we'll use a compact package, rooftop package air conditioner. But overall that's the setup, and in the next videos we'll start to employ all these things, usually this side of our secondary side, and we'll look at the different types of AHUs which we have, which are usually used in our systems. And I'll also explain some of the advantages, disadvantages, history, efficiencies and everything when I go into each of the different AHUs which we have. Thank you.